Welcome to my laboratory, where today we're going to be demonstrating a unique and exciting experiment with the combustion of yellow phosphorus in an enriched atmosphere of oxygen. And here I'm going to make the oxygen by the catalytic decomposition of hydrogen peroxide using manganese dioxide. Here we're simply just filling a flask full of enriched oxygen, and the cloud of gas that you see is simply vaporized water and hydrogen peroxide, which I'm going to let settle. In the bottom of the flask is some water to absorb the phosphorus pentoxide and also just to settle down any hot drops of molten phosphorus that may fall to the bottom of the flask and might cause it to crack. So we're going to fill this full of oxygen, and then we're going to take our piece of yellow phosphorus, which I've got stored under water. Yellow phosphorus is extremely reactive to the air and will spontaneously combust. And I'll show when I take some out of the water, some of it beginning to fume to give off phosphine gas, which you'll see just in a little moment as it fumes in the air. Now I've scraped this yellow phosphorus, which as you can see is a yellow waxy, very, very toxic substance. It's almost, if not more toxic than arsenic. It would take about 15 milligrams per kilogram to cause great harm. So if we take it out of the water, you'll be able to see it begin to fume again. It's a yellow waxy substance, and I've scraped off the oxide layer off it so that you can see that it's gone slightly dark because it's been exposed to sunlight, and it's changed into an allotropic form of red phosphorus. Yes, you can see it fume very clearly there. So I'm going to get it back into the jar under the water safely so that it doesn't burst into flames. Now, phosphorus was discovered first, as far as we know, in 1669 by Brand, and yet in 1777 by Lavoisier it was then classified as an element. Now we're going to take this small pea-sized piece of phosphorus, which is covered in an oxide and red phosphorus allotropic layer because it's been exposed to the sun as well. And what I'm going to do is put that onto a deflagration spoon and heat it up, and then we're going to plunge that into the oxygen. And from that we're really going to, I suppose, copy a wonderful painting done by Joseph Wright of Derby in 1771, and it shows the alchemist discovering the philosopher's stone. Wow. Lots of clouds of phosphorus pentoxide there, which is not as poisonous as phosphorus trioxide. Whenever phosphorus is burnt in less oxygen, it produces phosphorus trioxide. Now we've got some just universal indicator here, and we're just going to show that we have phosphoric acid formed by the phosphorus pentoxide dissolving in the water, and there we go, it's turning red. And here we have a nice slow-mo of it, so I'll let you watch it and see how much light is given out, hence the name phosphorus, the giver of light. And of course you can see why yellow phosphorus is used in flares and such pyrotechnics, because it easily gives out so much light when combined with oxygen. Later on I'm going to probably produce my own yellow phosphorus from the distillation of urine. That's another experiment I'd love to show you. And you can see the lab there being filled with copious amounts of phosphorus pentoxide. And that's only using a small amount, about 0.5 grams of yellow phosphorus being burnt in an enriched atmosphere of oxygen. Wonderful demonstration, one of my favourites. Please like, ring the bell and subscribe, and I hope to bring you lots more exciting demonstrations.